It says to draw a diagram. I can't draw a sphere though. It's a ball. So the volume of that ball is 4/3 pi r cubed. That's the volume of a sphere. And we're talking about the radius of the sphere increasing. So the radius is changing, and it's changing at a positive value because it's increasing. That's a +3. And then we're supposed to find the rate of change of the volume. We want to know V prime when the radius is at 24 meters. Now the temptation is to just plug all this information in, but what we actually need to do first is find out a formula for V prime. We need to take a derivative of this with respect to a variable that's not explicitly written here. S isn't written anywhere in this formula, right? But S is underneath everything. The number of seconds that have elapsed really changes this thing because the radius is changing by 3 meters per second, so that's changing the volume. When you take a derivative, just remember, you're using implicit differentiation. You're taking a derivative with respect to time. Now, here, when I take a derivative of this term, this is our first variable, the 3 comes down and multiplies. So I cancel out with that 3 in that fraction. Gets reduced by 1. But then the chain rule has to apply because the derivative of this function isn't 1. The derivative is r prime because it's a derivative with respect to time. So that's our formula for volume. We can clean it up a bit. So the 3's cancel out. Now if we plug everything that we're given in, we can solve for V prime finally. And r prime was 3. It doesn't, so I assume it wants our answer in terms of pi because I didn't see instructions about decimals. So I got 6,912 pi. Or if they do want a decimal, and if just didn't copy down the instructions, looks to be 21,714.74 roughly.